Okay, before the break, we were very, very slowly going over some interface stuff, stretch that out because it's an important point I wanted to stress. It'll save a lot of time if you can pull the information you need for your script off of the interface. So we were talking about that. One more quick pass at that with maybe our input object, and we'll kind of customize one of our input objects just as a refresher, because it's a very important thing. It'll save you a lot of time, right? You have to write 300 or 400 lines in a script and have to look up the words you need in almost every single one of those lines. It's going to slow the process down a lot. So I'm going to do this notation one more time on one of the inputs. And at the end, we'll see a better way to do the input objects. But maybe just a text field, and then we'll do a custom message or something. So I'll make a method called public. Again, we want it accessible from the outside, so it needs to be public. That way it shows up in that list of options there on the button. And I'll call it set input. And then create the things we need for that. Oops. In set input. And then once again, the labeling the closing curly braces in C family languages is just a good idea. It's good to get in the habit from the beginning. As your scripts get more and more complicated, that becomes more and more useful. So for our input, I'll just do the text field, and then we'll see a better way at the end to do those inputs. It's coming from a text field, so we'll have some string data. Ask the computer to give us space and RAM for a string. We'll call it input. I'll just go ahead and initialize it to a blank or an empty string, end of instruction. The semicolon means end of instruction, so we have to put that at the end of every single line. You don't want to forget that, but the compiler will let you know if you forget a semicolon or your curly braces get off. And then we have, once again, we have a thing on our UI that we can access. I'm just going to go with the parent object of everything that shows in our game, and the invisible stuff that doesn't show, the just generic game object, because everything is a game object. And it's text. So for the Hungarian notation, I'll start with the same prefix, txt input, and we'll assign it from over here. So I'll hit save so that the compiler will run and come back over here. And after the compiler runs, we'll have a new variable showing in our components that we can add stuff to. So all that really slow, stretched out stuff before the break, because that'll be a useful thing. And now we have that variable we just created is accessible from over here. And once again, that's how you'll find all of these values. And notice the thing we want is called input field. So I'll drag that over and assign it here to our script the same way. And I'll click on it and look at the components again. So we have this input field object that we added a bunch of objects to. We added a rectangular transform, a renderer, an image for it, and then an input field component. So that's the one we probably want. If we scroll through here, we'll see there's a bunch of colors, some tinting, fading on it. Oh, there's a text variable to it. That's probably the one we want. So if I start typing, you'll see that's what gets typed into that box. So yep, that's the variable we want. We want to access the text variable from the input field component. So when we go to access that, we're going the other way this time. That first time we access the interface and then put that into our output string, or assign our output string to that. This time we want to take what's on that interface and assign it to that input string. Whoops. So the variable we want to put it in is going to be assigned, but we're going to look at that input field. and then get a component from it. And we just looked at the list, so the type of component we want to get from it is input field. And we're getting something, so that's a method. Don't forget your parentheses. And that input field component has a text variable to it. So we want to access that. We're going to access that text variable from the input field component of our text input and assign it to our input. Notice which way I read that instruction. I read that instruction right to left. That's one that throws people off a lot of times because we write things right to left, but that's not the way they run. For example, this line. This is an actual code, but something you all are familiar with. Those instructions work, right? We assign a value to X, then we increment X, and what's the value of X down here? Well, hopefully everybody's well aware that this instruction does work. And this is a clear indication that our computer instructions, what we're putting together here, goes right to left, not left to right. Because we're going to increment the old value and then assign it and then replace it in that spot in memory. So kind of the same thing here. We say end of instruction because it's at the end, but when we read that right to left, that's almost like saying next instruction. So next instruction, grab the text variable, and going this way, our dot becomes from. Next instruction, grab the text variable from the input field component of the text input game object data, and then assign that to the input field. Then we can maybe print out a custom message. So output, I'll reset the output value variable. Then output equals, I don't know, well, hello there, plus whatever's in the input. Make it a name thing. I guess that's part of our first class on C#. So our concatenating strings is just the plus sign, just like we saw in Python. So that should look very familiar. For concatenating strings, just plus the value in the variable, then plus the dot. You don't have to worry so much about casting like you do in Python, because Python's open type. The computer figured out what type of data we have. Here, it's strictly typed, so the computer already knows that things might not be the right type. So there's implied casting, if it can. We might see it today. Whenever we create an object, one of our rules that is actually already filled in the background here, so we probably won't see it today. One of our rules is we do have to say what it means to turn that into a string. And in the C family, simply concatenating it is enough to turn it into a string. Now I'm going to make another method, another public method. Again, it's a void. It's just going to do stuff. It's going to change things around in the interface. So nothing to return afterwards. And some sort of name. Handle button click. I meant to make this one before the break so we could see that. And this is what's going to happen whenever we click the button. So we'll do this every time. In this case, we'll call that set input method, which gets the thing from the input field. And then we'll call the set output method to put that output string we built up onto the output. And then the rest for the next half an hour is what I expect we'll cover basic C# syntax here in this method. After this quick test and making sure this works. So over here, after that compiles, one quick change to the button, I want to change what method's being called. So I'll go over those steps again because it's an important one. So I'm gonna, with the button selected in the inspector on the button component, we have a list of things that happen when it's clicked. So I'll hit minus to remove that last one. So we need to add things to that list. The button itself doesn't know about any functions we can call. So we have to refer to another game object, which we can just drag and drop into that box. And now we can ask for functions off that game object, including the script that's connected to that game object, which has a handle button click. And at the end, we'll come back and see the inputs with a similar list to that, because it's a lot easier to work with than doing it in the code. So just a quick check to make sure this works. Can enter my name in the input field, click the button, and get a nice little custom message showing on the screen. So now instead of that, we'll come back. Yeah, that was mostly to review that syntax again, because that's an important point about how to get the information we need from the user interface. Let's just do our basic C# syntax now. Move those down, notes out of the way, and go back to the example. So start with just some basic math. So I'm going to create some variables X and Y. And for those who have seen strictly typed languages before, you probably saw everywhere to use double precision floating point numbers when we say what type of thing we have. With game engines, with games, there's almost always a lot going on. Double precision floating point numbers are 64-bit numbers. So, and there's so much going on in a game, we generally prefer to cut that in half. If we can save 32 bits and use a 32-bit floating point number, every place we need a number, and there's a lot of places in games we need a number, the background stuff that's built into the engine and the stuff we do. So those 32 bits are going to add up very, very quickly. So we tend to use floating point numbers. So our data type, and when we're inside of a method, we don't have to say public or private. Public or private are for the top level things. Anything inside a method is local and private. It only exists inside our method, and it is private. We can't really access it from the outside. So this is the math section, so I'll just call it X and throw in some floating point number, maybe something like pi. And there is something we need to do though. We want to keep that as floating point numbers on the way through when we work with it. The computer the language itself will often try to default to double precision floating point numbers. That's usually what we use in business sort of situations, is we typically have plenty of RAM to spare, but games are going to be big things. So we want to save that. We still want to look at saving bits when we can in game development. So whenever we declare a floating point number, we want to put an F at the end. And that'll keep that value as a floating point. It won't add those 32 bits back onto us to do other stuff. So all your floating point numbers are going to be the number and then an F tacked on at the end. Same thing for Y. I'll make it a floating point number. Integers would follow most of the same processes. Obviously, division and modulus are going to be different with integers, but we'll express those differently. So data type, give us enough room in RAM to store a floating point number. We're going to call it Y. In your actual scripts, you probably want a better name than Y. And then some sort of value to it, maybe 2.82. And it's a floating point number, not a double. So I'm going to put that F there to help indicate that. And then our math is probably what you would have can predict. So like float sum is x plus y. When we subtract floating point numbers, we get back a floating point number. Or if those were integers, when we add integers, we get back an integer. Same thing with subtraction. When we subtract integers, we get back an integer. We get back the same type of number we add, subtract, or multiply. Floating point number for difference is x minus y. When we multiply numbers, we'll call it product or abbreviate product, x times y, we get back the same type of data. So if we're multiplying integers, the result's going to be an integer. If we're adding integers, our result's going to be an integer. And since it's strictly typed, you do want to pay attention to things like that. Division's different because we oftentimes, if we divide numbers, when we divide numbers, they're not going to work out evenly. So the generic, if we have a floating point number, it will do floating point division. So I'll call it quotient 1. Yeah. Oh, quotient F. That's a good name for it. So floating point quotient, x divided by y. So here we have 2 floating point numbers. So it's going to do floating point division. If we want to do integer division, we just feed in 2 integers. So maybe integer, the quotient from integer division is like 7 divided by 4. We're feeding into integers, so it'll do integer division and only give us that quotient. So if we want the remainder, which would also be an integer, 7 modulus 4. So most everything there was probably anticipated, right? And then we'll need to put that somewhere in the output. So I'll reset the output variable and then build up a string. Output plus equals sum plus the sum. Output concatenate assignment. Oh yeah, we do have assignment operators just like in Python. So we can abbreviate the statement output equals output plus whatever was an output plus some new stuff. We can abbreviate that with just plus equals, which it's strings, so concatenation assignment. And this point was mentioned last time we looked at some scripting things. With computers, lots of small steps is better than one big complicated step. Remember, machines only do small things at a time. So splitting your instructions up into lots of small steps is better for the machine. Our difference plus whatever's in that diff variable. Oh, I should probably add some line breaks in there. Plus \n for the line break. So concatenate an n, concatenate a \n for a line feed. That way we can see all these. Output, we'll concatenate on the result from our product operation plus a line feed, end of instruction. And then we'll just build this string up slowly over a few steps. Along with being better for the machine, it's also a lot easier to debug. If something goes wrong, we don't have that big long string that stretches off to the side, or we don't have to turn word wrap on in our code to find problems that dig through a big long mess of things. We can go right to the line that has just that part that went wrong. Float division plus quote F plus equals int division, I'll just call it division, is the quote int value plus a remainder of whatever we got from that remainder variable. Oh, that's the last one. I don't really need a line feed there. That part should look very familiar. That's almost identical to what we would have seen in Python. The difference in Python, if we wanted integer division, we use 2 slashes. But here, if we want integer division, we just feed in integers. And if we want floating point division, at least one of the numbers has to be a floating point number. And building up our strings is almost exactly the same as Python, only you'll notice we don't have to cast all those into strings. Which I should probably go run this so that you can see that doesn't crash because we didn't put the str around everything like we have to do in Python. Most of that was probably somewhat predictable. Any questions about that basic math stuff? Obviously, that'll be important in your game, right? Your speeds are going to make a difference. Oh, and the error messages are nice. On line 46, at character 32, the compiler noticed something spelled wrong, a name it doesn't recognize. Quote underscore int. Oh, and then the next little warning is useful for that because quote int is assigned but never used. So it also noticed that where that typo kind of came from. That was short for quotient, not quotation, so I shouldn't have had an E on it. Line 46, character 32, told us exactly where that's at. So we go over here, save that, and recompile it, and hopefully it'll run now. And if you're in Visual Studio, you have to wait for it to compile twice, which isn't that long, but sometimes we get impatient, especially if it's just fixing one letter, and then having to wait for the computer to compile the same code twice. So when I click the button, oh, there we go. We got all those numbers. So we added pi and e and divided them, multiplied them together. And when we just divided them, we got the floating point division, which integers would do the same thing. You just have to be careful with the strictly typed. You have to say what type of data you have each time. And dividing regular division, we got 1 with a remainder of 3 once we fed some integers in there. And just to make a point and to show casting, if we want to change the type of it, like maybe here we wanted floating point division for the 7 divided by 4. Probably not, since the output goes right with the remainder. But if we want floating point division, one of the numbers has to be a floating point number. So to cast, like if it's stored somewhere, you can change it to float. We could have put 7.0 since we had the exact number there, but I want to show C# syntax. So if you have like 7 stored in a variable Z, we'd say right before it in parentheses, right, the type of data you want to turn it into. So that'll turn 7 into a floating point number and then divide it by 4. So then we have floating point numbers going into division. So that should give us remainder division. Whoops. Oh, then you'll notice that through another error. Cannot convert float to integer, because now it's doing floating point division, but we said that's going to be an integer. So we need to change that to a floating point number. So the type, keeping track of the types does take some getting used to. It runs much faster because unlike Python, the computer doesn't have to waste time figuring out what type of data it is because machines aren't intelligent. So they are actually not very good at determining on their own what type of data we have. It's much better for an intelligent human to do that. You can see now we get floating point division. 1 3/4, which is what we had before. But that covers, if we have the wrong data type, we have to do something like that. I'm going to send this file out afterwards, so I want to make sure and put some comments in there. What was that? 7 divided by 4 was the original. Alternatively, there we could have just put a 0.0 since we typed both numbers explicitly. But as long as one of them is a floating point number, it'll do floating point division. And just remember your type when you send that back. Probably could have guessed most of that. My example has list next to this, so I'll come back and do list. Selection structures. Next. Put some labels here. Math. So down here, I guess we'll come a couple steps down and do the selection structures. I'll just do a couple integers this time. 3, int n is 4, and int k is 5. That's enough to make some decisions off of. So the syntax here is going to look very similar. Let's see. If m is less than n, make the output say m is smaller. Don't need anything fancy here. I'll keep it as a trivial example. So just like you've seen before, our basic selection structure is just the if block. It can stand on its own. If that, the keyword if, then our condition goes in parentheses, and then curly braces to define the block of code that's going to happen if that condition is true, or whenever that condition is true. Come over here and run this, and then I'll do a little bit more typing before coming back. So our basic one, but the compiler and waiting for it to run kind of takes up time. So let's do a couple of these. So we can also do if else. So if m is smaller, then if m is not smaller, it'll jump into the else block and say the else is smaller. Then we can combine conditions. We've seen that, our logical operators, right? So our logical operators are based off symbols. So we can check between all three of them and figure out which one's the smallest, which in this case is trivial because we just assigned them. But looking at the syntax for the if else, and here in just a second, the else if. So to check m, we need to know if m is smaller than n and smaller than k. And to do an and is 2 ampersands. And m is smaller than k. And to do if else, which is like elif in Python. Remember, white space matters in Python, so we had to combine that, and we couldn't have a space between them. But here we can't have a space between them, so we actually go ahead and write both words. So if this condition's true, do that stuff. If it's not true, then we'll check another condition with else if as 2 separate words. Then we'll check if n is smaller than m and n is smaller than k. I'll put the notes up here. So 2 ampersands is and, 2 pipe symbols, that's the key shift, and then the key right above your enter key. That's called a pipe symbol. 2 of those is or, and your exclamation mark is not. So there's your logical operators. So if M is smaller than N and M is smaller than K, then it's smallest. But if not, then we can check if N is smaller than K and if N is smaller than K and N is smaller than M. But if neither one of those is true, then we can throw in our default, say output K is the smallest. If it's not either one of those, it has to be that third one. I could run this and switch it back several times, but I think mostly I'm just going to run it a couple times just to check it. Because there's different combinations we could run here to make sure that works and gives us the correct value every time. But with having to compile everything and wait for it to run, it can get a little slower. So M is the smallest. So if we change M to 13, now we should see that N is the smallest. So once again, wait for it to run, recompile for changing one symbol there, run it again. So you can see there's an extra little bit of time thing working with the compiled languages instead of interpreted languages like we saw earlier in the semester. So N is smaller, no typo. I'm going to assume that kind of works the same way and move on to the next section just to try and cover our basic syntax as quickly as possible. Because that first part stretched out even further than I admit for it to. So now I'll reset that output value variable for the next thing, which you'll probably have a guess of what's coming next, right? Saw our variables, saw our selection structures. I don't think this is anybody's first programming course. Well, it can't be a first programming course because you would have had to take the SDEV 120 class at least, Intro to Logic. So you remember what comes next? Loops, one of our 4 constructs. We need 4 types of tools to solve any problem. We need a sequential tool to order things happen in, which that's built into every programming language, especially the text ones. The order is the order we write our instructions in, going top to bottom. Then we need a selection tool, some sort of selection structure, way to make choices, if else structures. So there's syntax for that. Then we need a reiterative tool, ways to repeat steps. We have recursion in machines, but that can be very difficult to work with. So most of our programming languages have loops. C# is one of them. We also need invocation, but if we're in an object-oriented only language like C#, that's already handled before we get to anything else because everything we do has to happen inside of methods. So our invocation of invoking an object and then invoking a method inside of that object has to be set up before we can even do our simple math. So the next one, we need to see loops. I'll just set up some sort of counter equals 0. And then we can, a keyword we've seen before, a while. And just like our if structure up here, our condition goes inside of parentheses. So while counter is less than maybe 8, we'll just add it to the output variable. Output concatenated assignment. So reassign output to whatever it was plus a little bit more, and we'll add to it the number is growing. Trivial statement because we're just looking at the syntax here. The important thing in this pass is the keyword is while. Our condition goes in parentheses, and then an opening and closing curly brace define the block of instructions that's going to run when that condition is true, for as long as that condition is true. The number is growing plus whatever the counter is plus line feed. End of instruction. C family language. I remember that end of instruction character. Oh, and then we need to increment our counter. Well, counter equals counter plus 1. That's a very common thing, right? To reassign a variable. I think most textbooks will call that's commonly abbreviated. So if we're changing the value that's already there, we have a special operator to do it. Counter plus equals 1. And that's just a common abbreviation because that's so common. And a lot of our languages, Python didn't have this, so we didn't see it earlier. But most of our languages take that a step further, because most of the time that we're reassigning a variable, we are doing it by 1. Right? Such in the case of counter equals whatever was in counter plus 1 more, or minus 1 more, and almost just as often it's a 1. So there's even a special abbreviation for that. Counter plus plus increments by 1, and counter minus minus decrements by 1. So we have the special increment and decrement by 1 operator, just plus plus, because that happens so often. But that's the same as counter plus equals 1, counter equals counter plus 1. I'll go ahead and type all 3 of them, since I'm going to send this out after class for reference for you all. Since we're going through it awful quick. And once again, what I did each time was change that global scope output variable, because we're already set up to throw that onto the screen when we click the button. So for our pass here, we're just changing what's in it. I ran out of room, but you can see it kind of ran. I can click over here. It didn't freeze up, so you can see that it eventually stopped. We didn't go into an infinite loop. I can still check and uncheck the box. A trivial example, but the main point is the syntax. Keyword while, set up our counter, then curly braces to define the block of code. We also have for loops. So I'll do a for loop here, reset the output, the variable we're going to use, and basically do that same thing in the other syntax. So for, and with a for loop, this is what we pretty much always do if we have a counter. Typically, while loops have fancier conditions, like while the input does not equal a certain value, sentinel values, that sort of thing, that's going to change. But this is very common. We set a counter, a condition to watch that counter, and then increment that counter. So that's what our basic for loop does. It's all abbreviated in the parentheses. So keyword for, and then in parentheses, we set up an integer to be a counter, which will start at 0, followed by a semicolon, because that's one independent instruction. And there's kind of 3 here. Create our counter, set our condition. So while I is less than 8, which didn't fit on the screen, I is less than 5. Whoops. I think 5 fit on the screen. Then I plus plus. That's such a common thing that our for loop is really a structure to work with that. Then I'll do the same thing. Output plus equals, the number is growing. This time our number is called I, plus a line feed, so that it doesn't just run off the side of the screen. It kind of goes down. So that's our basic 2 loops. And then the main thing that's going to change is what condition are we looking at to know when to loop. Both of them are true conditions. It happens as long as the condition is true. And then we exit our loop when that condition becomes false. And then what do we do inside the loop? That's obviously unique for every situation. So I'll come back over here and run this, but it's going to do essentially the same thing as the while loop. Yeah, The only difference there is if I would have made a typo while talking and the compiler threw an error that we needed to address. So 0, 1 through 4, so it stopped whenever it got to 5. Hopefully at this point, you know enough programming to not be surprised by anything there. What is the next? Oh, arrays. I'll put those up here in my example. I put the list up by variables, but I wanted to talk about for loops before looking at the list. So there's lots of types of things we have. We're in a strictly typed language, so we do fit that technical definition of array. For those who've had me in class before, you would have seen, would have gone on kind of at length about that. We also have multiple types of data structures. We have queues and stacks and priority queues and all sorts of things built in. We have an array list. I'm just going to do a simple list item, which is a type of thing, a list, but then it's strictly typed. So we have to say what sort of data we're going to store in our list. So angle brackets, just like we saw before up here, where the angle brackets define what type of thing we have, which some of you all may have seen that in HTML. And that's the exact same thing it means in HTML. The HTML code we write does run through a C family language before it shows up on the screen of the browser. So it means the exact same thing. The angle brackets are the type of thing we have. Although in HTML, it's all types of text, various types of strings. So for the first one, I'll do a list of strings. I'll call it names. And that's going to be a new, we need the keyword new list of strings. And then we need quote marks on the right-hand side one, because that's actually a constructor. That's going to go through a whole bunch of stuff in the background to create that. Constructors are important in object-oriented programming, but not necessarily going to show up here. In Unity, the Unity game engine, everything we have inherits from stuff that has constructors, and we don't want to override those constructors. Some things it's a really good idea to change, right? Our start method and update method, it's really good to change those every time. But some of our other methods, we don't want to change, like our get component. It'd be a really bad idea to change that. And constructors are kind of the same way in Unity. We don't want to go change the constructors because it's a big, complicated scenario that we could miss something if we do it. I guess I'll use, so now that we have, when we have a list, obviously it's still empty here. With list, I was looking for some simple syntax. So an easy start, because you're going to want a list of data in your game to work with at various points, right? You're going to want a list of NPCs in the village. You're going to a list of mobs on the screen to take care of. So that's going to be an important one. So I wanted a nice clear syntax to start with. If we just do a simple list, we can work in any type of data we have. So in those two examples, your item type would be game object, or explicitly your NPC object, something like that. And we can add in some names. So Bob, names dot add Sally, names dot add Becky, names dot add David. Those are completely arbitrary names. Those who have had me in class before have probably seen that there's a list of 10 names that I choose in order. Very common names. Maybe it's people I've known in my life, because I have known people by all those names, but it's always the same list of names that I use. It doesn't refer to anybody explicitly here, but it's a list of things. And then we can use our for loop to go through that list. So like we just saw the keyword for, and then in parentheses, we'll set up an integer that starts at 0. Our indexing in arrays, an array list, linked list, and every type of data structure, our indexing starts at 0. We'll go while I is less than names.count, and watch the capital C there. A lot of our other languages that use the keyword count have a lowercase c, so that one does throw me off quite regularly. It is a capital C in C# to count things. Then we'll increment that, and in this case, whoops, I forgot an I. In this case, I is our index, so we can just ask for each one of those. Output is going to be reassigned. Oh, whoops. I'm going to come up a couple lines and put in something I forgot to do. I'm going to reset output. Maybe it was empty at this point. Maybe not. It doesn't hurt to empty it if it was already empty. So I'm going to make sure it's empty and then add stuff to it. So we'll concatenate on from that names list, index I, so square brackets, that should look familiar to everybody. That's pretty much the standard. If it's just a word, that's a variable. That means store a single data point. If it's the reference name in parentheses, that's a method. That means do something. And if it's the reference name in square brackets, that usually indicates a collection of things that have some sort of indexing in it. So a list has numerical indexing that starts at 0. So we'll output that plus a new line. I was going to run this and then do another thing, so I'm going to just kind of jump and do the next thing because it takes a while. So I'm going to add a little break point there, a little mark to indicate it, because along with the add method, we also have a remove method. Names.remove, oh, capital R, names.remove, I don't know, we'll take Becky off that list. I won't be able to fit that many things on the screen. So I'm going to change that line break to a comma. And then afterwards, I'll do a line break, then a line feed, remove Becky, and then we'll print that out again. So copy and paste. And there's no need to change it because that for loop just goes through our entire list. So all I did was change the line feed to a comma because I remembered from the font size, it only fit 5 lines on there. So we're definitely going to run out of room here. So we'll put all the names in a row, then put in a line feed with some separator stuff, then another line feed, remove the name Becky, and then all of that. Hopefully it makes sense. List is the keyword. Then in angle brackets, we have to say what type of thing we want, what type of data we're going to put in this list, give it some sort of reference name, and then that gets assigned the keyword new. Again, list with the type of data it has, only this time it gets parentheses on the right hand side. So copy and paste that part and add parentheses when you get to the right hand side of that statement for list. Yeah, so I'll go ahead and run this. Uh-oh, the name output does not exist. On line 60, character 9. So line 60, here it is. Oh, that must be where they're talking about. Fix the typo. Oh, that happened twice. Oh yeah, because I copied and pasted that line, didn't I? So just a little typo from when I was talking and typing at the same time. Hopefully that's fixed now. Okay, there we go. So when we run that, the typical should have the typical thing from array where we keep lots of data in a collection of them. For those who have had me in class before, I like to use a backpack example. It's the difference between carrying a stack of items to school and walking around all day with your stack of items. That's the loose variable, whereas a collection like an array or a list is a backpack. Oh, whoops. That does need to be at the bottom, doesn't it? I put it up there because it made more sense in my mind to have it by variables. But I forgot all this other stuff happened afterwards. So I'll move it down there. So it's the last thing that happens. Because it would have happened somewhere in there. It just happened so quick we couldn't see it. Oh. I have to stop the previous run. There we go. So you can see we have a list of names, which that's going to be very useful in your games, right? Like ones I mentioned, when you get to a village, you're going to have a list of all the NPCs in the village, and or a list of all the mobs on the screen at a particular time, and put your data into a collection to work with. Those who have had me in class that covered that have seen it's the difference between carrying a stack of items to your school day or putting everything in a backpack. And then just like the backpack, whenever we want something, we dig through and maybe put an if else there and check every single item in that list to see if it's the one we want. So set up the list and a for loop to dig through it. I'll do one more list with a different type of data. So maybe this time list, and let's do it with integer data. Yeah, that'll work here. For a second, I got confused with, in Java, we can't use the lowercase e. We have to use capital E. C#, it's okay. We can create a list of int data, which is going to be a new list filled with integer data, which we need parentheses on the right-hand side. And then we can just do the same thing. So like numbers dot add a 9, numbers dot add 7, numbers dot add 3.14. This time adding something that's not an integer to see that error. So that's, instead of carrying a stack of data, it's like put it in a backpack. So then when we want one of them, we'll dig through. And obviously that's not an integer, that's going to throw an error, but I wanted to see the error message. Y'all seen that before in class. I like to throw the error messages to see how to fix them instead of just seeing the final correct result. So we'll loop through it by setting up a for loop. Whoops. For an integer, we'll call I, assign a value of 0. Well, that's less than numbers dot count. Keep incrementing that index. And then inside curly braces, we'll just add it to our output. Output is the next number is plus that numbers list index I plus a line feed. There's only a couple things that'll fit on this one. And then if we wanted to get rid of one, we could have the remove method. Obviously, that's not an integer. I wanted to look at the error when that pops up. So cannot convert from double to integer, so it has the wrong type of thing. So one thing we could do is do our casting. I'll just fix it that way, using that casting again. 3.14 is not an integer, but if we cast it to an int, actually, let me type in a different number. Let me use the other one I used, 2.82. So that's not an integer. If we turn that into an integer, what number are we going to get? Does anybody know? So that cleared up the message because we cast that floating point number of 2.82 into an integer. So I guess the only question left is, does it round it? Because 2.82 would round to 3 in both the simple American system and the metric system, which is more accurate, but very, very complicated for those who went to school in places other than America, saw the complicated rounding. But either system rounds to 2.82 to 3. Or do we get a 3? Does it just truncate it? Or sorry, do we get a 2? And you can see that if we just cast to an integer, all it does is truncate it. So be careful with that. If you cast it, make sure you round. Add 0.5 before truncating. And that gets the simple American rounding. Because then if it's above 2.5, it goes up to the next integer and we cut off the decimal point. And if it's below 0.5, it doesn't get up to the next integer, so when we cut off the decimal point, it goes down. So to round, make sure you add 0.5 and then cast it. So what time is it? 2:32. There's 3 that, okay. So 2 things left on the list. I was debating on cutting this, but I think I'll go ahead and include it. Because when sometimes things go wrong. And we have 2 types of going wrong. We have errors and exceptions. Errors are unrecoverable. That's bad things. That's like the battery ran out of power and shut down. Nothing that can help. Exceptions are little hiccups that we can work around. We can handle exceptions. So exceptions are like a small leak in a boat. Things are getting a little damp, but it's a boat. Obviously, things are going to get wet. An error is like the boat hit an iceberg. There's no recovery. So exceptions, we want to deal with those. I'll do the basic one in A equals 3. Int b equals 0. So if we want to divide those, we hit a problem, right? So to kind of deal with it, let me reset my output. Gets reset first. Then let's say floating point number C is, we'll cast our variable A into a float and divide by our variable B. That's what we want to do. Output, we'll throw a C, then we'll throw that C on there. But we're dividing. So we have that problem of division by 0 would give us trouble. Typically that's something we would do if we were getting input from a user, right? We're going to ask the user for a number, and then we're going to divide it. But if the user gives us a 0, that's a problem. So we can try to divide the number. And if not, our keyword is just catch and do something else. Output is cannot divide by 0. Moving on then. We'll just print out that word, we'll just print out that sentence and then move on without doing the division in this case. So we can our program doesn't entirely crash. So if I run this like it is, I'll add another line in there. We can build up a string of things. Build up lots of exceptions. I.e., we can say catch, and then in parentheses, put a particular exception, like maybe an IO exception, and call it E, and then we can do stuff with it inside. I'll just put that syntax there for reference purposes. In general, I just do the overall catch anything that goes wrong and handle it all at once. But we have lots of specific things we can deal with each one separately. I'll just put that other reference in there for people who know about exception handling. If you haven't seen it, just a simple try catch is usually enough. So if we run this, currently B has a 0 in it, which will cause a problem when we go to divide. Wait, why didn't that? That didn't throw an error. We'll try doing something different. That did throw an error when I was preparing, so I don't know why it actually worked at that time. It wasn't supposed to. Okay, so that time I did something I couldn't do. This time the error was I divided two integers. I don't know why it didn't like that. But when we divide two integers, the result is an integer. That's integer division. And I tried to stick it in a floating point number. It's like, oh, something's wrong here. So I'll just put in that line didn't work. That instruction did not work. A trivial explanation of what exception handling is. But if we have something that works, it will go ahead and run that. So if I comment that out and say int C is A divided by B. Now we have the right type of data here. Oh, I keep leaving that running. I shouldn't do that. So stop the previous run. And notice that error message, the reference script unknown on this behavior is missing. That popped up when I left the previous run going and then recompiled the code, because it replaced the other one and threw all kinds of stuff off. Now it should be able to do that division, gives the integer division result. So one last thing I had on the list. So there's another thing, and it's going to be important for gaming, right? Because the game you have in mind, maybe not every game you have in mind, but some of the games you have in mind are probably going to be really big things, which means people aren't going to be able to sit down and play them beginning to end in one sitting. So how do we handle that? We're going to need to save it somewhere along the way. So I'm just going to do the simplest saving, just a simple sequential text file. So text file IO. Definitely you're going to want to save your games at some point. So like I've done everywhere else, I'll reset the output. And I'll make a new string here called for file. Here's a string for a file. Line feed, so \n for a line feed with 2 lines in it. End of instruction. And There are lots of ways that we can write to a file in C#. The simplest way, what I think is the simplest way, we'll need another library to work with. So if we scroll back up to the top, it's the simplest way isn't built into the thing. So we have to look at our other libraries. And it's not one of the ones on here. So we'll also need our program to be using the system.io library. Using system.io gives us the easiest way to write a text file in C#. And then a sequential text file, we just take our data like the character's hit points, experience points, current health, all of that, write it to a text file. And then when we want it back, we just remember the order we put it in the text file in, and then bring it back from that same order. Hence the name sequential text file. So using system.io library, system.io, when we have a string, so we'll take all our data, turn it into a string, put in a string, get ready for the get it ready to send to a file, and then all we have to say is file.write all text with a capital F and impact Pascal case, write all text. And then that will give us a file. I'll call it sample.txt. So this needs two parameters filled. So we send in 2 arguments. The first one is the file name with an extension if it's somewhere else, but it's only relative address. It's only relative addressing from where this file is running. So I'm going to point at where that's at here in just a second. And then what text do we want to write to the file? So file.write all text is a really easy way to do that. And you probably already guessed what the reading version is. So notice output's empty. So I'll go ahead, since the compiling and stuff takes a minute, I'll bring that back in, file out, and put it in that output variable. So our output variable is going to be file.read all text. You probably already guessed that one. And here we only need 1 argument, because if we're just reading it, all we need to know is what are we reading, sample.txt. So if those words show up on the screen, then that means it successfully wrote to the file, then read from the file. And the normal file handling stuff of closing and all that is built in, included for us. And that'll be important for games because we want to add save points along the way. That way the character doesn't have to start back at the beginning every time, right? So that can be a little inconvenient if you get it a long, long ways into a game, especially a big game. If you're 3.5 hours into a game and have to start back at the beginning, you're not going to be a happy gamer. There's probably going to be controllers get thrown, even from mild-mannered people or something like that. Oh, the word showed up. So those only came from the file. So that means it had to have been successful. So I want to point at where that's at though. So I'm going to go to where I saved this. I saved it in my delete folder, I think. Yes, class example syntax. Assets. And here's our script, on button click.cs. So that's our script. And I didn't add anything else here. Notice there's nothing else. I didn't say go up a level or I'm on a Mac, so I didn't say go back to the tilde/documents folder. I didn't put any other addressing in there to say where to go. Just gave that same name. But we can see here, it's not in the same place as our script. So what we need to do is go up a level. So I go up a level. Here's the project thing. There's that sample text file. So it's relative addressing to your project. So if you want to put it somewhere else, you need the ... to go up a level and then start where the project is stored and navigate with relative addressing to that other place. Otherwise, your text file will be on the top level of the project because that's where the things are actually running at. IO loops. So I think that's everything out of my list. Text file IO, exception handling. We had lists. I'll put an S there because we did a couple of them. Then we did loops. Put a label on that. Loops. We saw selection structures. And we saw basic math. So that's our general pass at the C# syntax. Does anybody have any questions about that? And I'm going to send this out right after class. Okay, the other thing we saw, which is probably going to be much more valuable to you, because that is, it is not just a Unity thing. Your other really powerful game engines are the same thing. The game engine is not the graphical user interface. The game engine is that library of programming scripts that we have access to. And the user interface has access to the same things, so we can get the values we need off of the user interface if we know how to read it. Does anybody have any questions about that point from before the break? Because that will be the more important one in the long run. So that way you don't have to go look it up for every single line. You can find the information you need on the user interface. I assume no questions about that. So remember, that stuff is mostly going to be in your inspector. If it's for a particular item, it's in the inspector. And if it's for all of your items, it'll be under edit, the project settings. So all you have to do is just ask the question, okay, is this a individual thing or does this go everywhere? The next thing I wanted to look at real quick before we finish, this will go really quick because they're kind of the same. I said there's a better way to do this. I just kind of did it that long way. Comment those lines out. I did it that long way to I'm getting a glare on my screen here. There we go. I need a curtain on this window. I'll have to remember that before the next class period. So I did it the long way, but said there was to express that point, but there's a better way to do those things. So let's look at these other inputs we have here, because you might want to use those some for your game. I'll do the text input first. So we had that. So a difference, we need to take in a string. Our text input, actually, I'm going to change the name of this altogether. I'm going to call it text input, and it's a text, so we need a string value passed in. And then once we get it, we can reset that output. Output equals that string we passed in, and then we'll call our set output method to run that. So basically all our method does is take in the string and put it where we need it to be. So in more realistic situations than a trivial pass at the syntax, well, it's still going to do the same thing. You're going to take in that value and put it on a global variable. And now when we call that, which I have to put my hand up here because I'm getting a glare on my screen. Guess it's time to bring out curtains. If we go to our input field, over in the inspector, We scroll down, you'll notice there's two lists that look an awful lot like that button thing we did where we added what we wanted to happen to that list. We'll do the same thing. So here we have two of them, on changed and on end edit. So from those names, you probably guess which one's which. So when it's changed, what do we want to happen? So we need to access that script, which is over in our game object. So I'm going to grab that and drag and drop here. Oh, I missed. Really need a curtain, but I'll get that for next time. And then on our on button click script, notice we have a couple lists now. So now up at the top, this input is pre-made to go with methods that expect strings. So we have this short list up at the top that has just this things that accept strings. Did I not save that? Oh, I have a little red dot there. I have the little dot there, so I forgot to save it last time. So let me save that and come back over here. And now after it compiles, fix the typo. And after all the typos are fixed and it compiles, now this list should have that on there. Obviously, it can't see it until it's saved. So from the on button click, there it is, that text input method. So it will automatically pass that over to the method, and then our string will just pass that in there. And I did that on changed, so it'll happen as it gets typed. Oh, oops. Run. So now when I start typing some words, you'll see they show up right there on the screen as it changed. On edit end, you can probably guess that happens when we type words in and hit edit enter. It doesn't show up until we hit enter there at the end. So you have an option on that one. But that's how all of these inputs will work. We just have to keep track of the data type. So for the slider input, a slider gives us a number between 0 and 1. So a percentage really, with 1 being 100%. So it's going to give us a floating point number. So we'll just set up a void method because we don't need to do anything afterwards. Your method might need to do stuff afterwards, but generally these are voids. We're not going to return anything. And I'll call this slider input. But when that slider gets moved, it's going to send us a floating point number, which I'll just call slider, because I can't think of another name right off the top of my mind. So I'll reset the output. Output plus equals the slider value. And then call that set output method to throw that on the screen. And I'll go ahead and type all of them to finish up for today because we only have a couple more, but you'll see they're the same thing. Actually, you can probably guess what they are. Public void, what do we have? Drop down input. The only thing that might remain as a question from guessing what it is what type of stuff do we have? If we look at our drop down input, as we scroll down, we'll see this list of options. And we can change those. Oh no, I'll put a couple words in there. Pizza, hot wings, cheeseburger. So I put in words. So our data type is going to be a string. So when we select something from that list, we're going to be getting a string. String I'll call option, and I'll do the same thing. Once we get that string, we'll just assign it to a global variable. Oops. And then we can use that anywhere else in our script. In this case, just to spit it back out to the screen. A trivial example, but this point would be the same. We assign it to a global variable that we use elsewhere in our script. And then once we get our inputs, hopefully that makes sense. Oh yeah, toggle method. I'll go ahead and write that, and then we'll go run them. So public, it's not going to return anything because we're setting that up from the interface. Once the game asks for it, it's not going to need anything back. Toggle input, and that returns a Boolean, which in our C family of languages is abbreviated. So our data type is bool, which is almost like his name. The guy's name had an E on it. So BOOL for the ones that are just true or false. And I'll call this checkbox because that strikes me as a better name. I'll reset the value. Oops. And then some sort of sentence to put on the screen. I'll do this. Normally, that's a true false value. We're going to do a selection structure. So this is about syntax, so we'll look at that. So if checkbox, and we don't need to make any sort of comparisons because this checkbox variable, it's holding true or false. So that is an entire condition on its own. If the box is checked, this method will receive true. So this part will run. Output equals that box is checked. Some arbitrary statement. But if it's not, if that comes in as a false, then we'll go down to our output statement, and output equals you need to check that box right there. An arbitrary sentence, but enough that we should be able to clearly tell whether or not it's working correctly. And that's our basic types of inputs. We can get in Booleans. We have two ways to get strings: the input boxes or the drop-down menu, or the slider to bring in a number. And then once we have a number, we could cast it as an integer or multiply it by 10,000 or 5 or whatever scale we need that number to be, and then turn it into an integer or any of our other types of numbers. Any questions? So then the last step is one we've seen. Once we have our methods set up over on our user interface, we select that that UI element game object, and there's that list over the inspector panel. In the slider component, there's this list of on value changed. So when it gets changed, we want to notify the game object and run that slider input method. Same thing for our dropdown. After we get our options in the list, and we can build up the list here, add some pictures to go with them. But when it gets changed, as soon as it's changed, we're going to notify that game object thing that it needs to run that the appropriate method. Which I don't see on my list. What did I do wrong there? Did I put the wrong type? Oh, I did put the wrong type. The drop down, I was thinking of something else. Sorry, I was thinking of something for my evening class that we might or might not get to this evening. The drop down actually takes a type of drop down. I'll call it DD. I should have looked at my example. And then when we want it, we have to refer to the whole drop-down option. So the DD, the drop-down object, it has a thing called options in it, which is a list or an array, things we can choose from. And one of our indexes that will be passed in with this, there's a value, right? Yeah, value. So DD options list, and then DD.value is the index of the item on that list. So both of those are being passed in, and we'll just grab the text from that list. Hopefully that makes sense. Sorry, I was thinking about a similar thing in Python that might start showing up in the evening class this evening. Languages start to run together very, very quickly. So that actually takes in the input itself. The rest of them just take in the type from the input. But now after this compiles, should be able to see that on the list. So when we change the value, we'll notify the game object to go to that script and run the drop-down input function. And same thing on the toggle one. Over in our inspector, if we scroll down to the toggle component, there's a on value change list. We can just hit the plus sign to add something to it. So when the value changes, notify the game object that it needs to run the toggle input function. It's very repetitive. Hopefully that made sense. Does anybody have any questions about that?
I don't have any questions.
Okay. Hopefully that'll get you all some stuff to get started with over the weekend. So our button still does that other stuff. But if I start to type, I put in my name, you can see it's changing. You also, with the text input, you also have that on end edit, so you can wait till the enter key is pressed. The slider, when we change that, see we get different floating point numbers. Something between 0 and 1. So if you need a bigger range, right, like if you want to go from -10 to +10, you could say multiply that by 20 and subtract 10. And that gets up to the, so multiply by 20 would give you 0 through 20, then subtract 10 would give you -10 to +10. Or multiply by 100 to get 0 to 100. And adjust that number once you get it. Input, uh-oh. That's not what I did on the option. DD options DD value text. So that looks right. Unity engine object cannot be. That sounds like something that's happening over here. So on this object. Oh, notice another field showed up when we loaded that in. It needs a dropdown. So we need to drag over the reference there. I didn't see that pop up. So watch for other fields that pop up as you make changes, because you might need to assign values to them. It's a dynamic interface. It's not like Microsoft Word. Your buttons aren't always in the same place. Sometimes when you click buttons, you get new things. Okay, that worked. So now when we change the items from the list, we get different options. And if we toggle this, well, toggle's not working. That one works. That one works. Why is toggle not working? Do we have other options there? No. I call the right method. Oops. Is that box in check? Nope. What am I looking at here? I was talking the whole time. Oh, I know what I did. I should have realized that sooner. That's a very common problem. We're thinking about the big steps that we need to carry out now. So I forgot the trivial part of write it to the screen after we get the sentences put together. I focused too much on the sentences. So usually if there's no error messages, everything looks like it's correct, and you're not getting any error messages saying something went wrong. That's one of the first things you should check, is make sure you remember to write it to the screen, write it to the output or whatever. There we go. It doesn't seem to refresh it though. Is that what that's? Is that an assignment I need to make? Well, something went wrong there. I think it's because I was talking the whole time I was doing that and I skipped a step. But it looked like they were all included. Oh, there we go. That's what I did. I chose the wrong one from the list. So we went back to it now. So notice when I go to that script, there's a short list of things that take in Booleans that this would work with, but there's a long list that has everything. And I click the one on the bottom and it didn't work. If I go up here and click the one on the top, it needs to be the one from the short list, the one that it recognized as a dynamic thing. is the problem there. Whoops. I didn't mean to double click there. So now when we toggle back and forth there, we get those different sentences. So that's how we set up our inputs. To pass it the C#, basic C# syntax, I'll send this out. And then that thing we started out with and went really slow at the beginning, how we pull the information we need for our script, the names and things we need for our script from the user interface. Hopefully that will be useful information for you all as we head into this holiday weekend. We won't have class again until next Monday, so it might be a good time to kind of click around on things, get used to it. Try to familiarize yourself with Unity. And like I said earlier, I guess I didn't make it clear the first time, I will accept custom work. The assignment says to follow along those tutorials, but if you want to do your own thing completely and build something from scratch, I'm okay with that. Give me a heads up on what you want to plan on doing. That way I can make sure everything's there, maybe make some suggestions on something important that we don't want to accidentally leave off if you do that. But if you do your own work, you also have to understand it. We can copy and paste from a tutorial without understanding what we're doing. So I don't mind seeing that. It does take some practice. You might want to click around on it. Hopefully that'll get you a start. I will send out that script we just put together immediately here. And otherwise, unless anybody had any questions, that'll be it for today. I assume that means no questions then. So I will see you all next Monday and we'll get started into, like we did before, an example game, a small game example put together with Unity. And we'll have a couple of those for the rest of the semester. Otherwise, you all have a great holiday and try to relax some on the days off. I will see you next Monday.
Yeah, have a good one, Chris.